So now we know how to graph a quadratic function when it's in vertex form, but how do we put it into vertex form if it's not when we're given it? Well, we just need to complete the square. Now, there's a couple of different methods we've used to complete the square, and we've done it perhaps slightly differently depending on whether or not our quadratic equation was equal to anything, or maybe it was just a quadratic expression. So either method works fine here. I'm going to show you two ways to do this one. The way that I like to do it in either case, though, is to leave a line and say, I'm looking for these two terms to combine together to give me something that's sort of got this shape to it. And I can see that if I expand this out, I'm going to get my first term just fine. But to get 6x, I need to halve the 6 to get 3. And that's because when I expand this out, the x times x will give me my firsts of x squared. But that middle term, which is made of the insides and the outsides, will be 3 times x doubled, because the insides and the outsides are the same. So when I expand this out, I'll always get my first two terms well enough. And that's quite simple, just to halve the 6 to get this one. But whether I like it or not, I'm going to get 9. And that's because the expansion of this has 9 as the last term. Now, two ways you can deal with this 9. One way is to say, oh gosh, I've added 9 and I wasn't really meant to do that, so I'll just take it off again. And this plus 9 and minus 9 can just act like they were never there. In fact, I was meant to have a 5, so I'll put that in now. You can do it that way. Now you can see that you've still got your y over here each time. And looking at your lines, you can tell that the first two are the same, because the plus 9 and the minus 9 is the only change that you've made here. But now you can see that these first three terms are all taken care of here, and that leaves these last two terms as kind of like the leftovers. And negative 9 plus 5 is minus 4, and now we're there. So now we've done it. We've got vertex form quite simply and easily, and we can see that our vertex would be negative 3, negative 4, and we can use those other steps to go ahead and graph this parabola. Now, another way that you might prefer to set it out, again, to leave a line and say I'm looking for this arrangement. I think that's a good strategy. I need to halve my 6 to get my 3, but when I expand this out, sure enough, I'll get my x squared plus 6x. I'll also get my 9, and I'm meant to also have my 5 here. Now, comparing these two lines, rather than take the 9 off again, if you want to, you could add 9 to this side. Okay. Now, you can see that these three terms are taken care of here. And here you have your plus 5 sort of hanging out the end there as a leftover, and over here you've got plus 9. Now it's almost in vertex form, but you want to get your y on its own again, so you can subtract 9 from both sides, and that will give you that minus 4 on the end. So whatever way makes sense to you is a good way, as long as you're getting it right. There's multiple ways to do the same thing here. Now I wonder if you remember that last time we looked at completing the square, we found that having a number other than 1 at the front here, or in other words having a non-monic quadratic, actually made the whole thing just that little bit more complicated. And the first step, which is very important, is to get rid of that 2 there so that you do have it as x squared. So think here, how do we do that? Well, we need to halve that term, but we need to halve every term, and there's 4 of them here. So work your way along the line and halve each term. If they halve nicely, go ahead. If they don't halve all that nicely, you can just leave them as improper fractions like that. Now we've got a situation that we can deal with here. We'll leave a line and we'll say we're looking for something that looks like this. Now, this part will take care of these two terms beautifully. So we rewrite those. When we expand this out, though, we're going to get positive 9 here. Now, whether you like to add your 9 to both sides, I think I prefer to just add it and then take it away again, pretend that it was never there. Now we've got still our y over 2 here, and over here we've still got our 7 halves. Now we can just check that everything seems right. From this line to this line, we've added 9, but we took it away again, so that's fine. Now on the next line, we can see that these 3 terms are taken care of here. We've still got our y over 2. And out here, these are kind of our leftovers. So we've got minus 9 plus 3.5. So I've got minus 5.5 there, and you can write that however you like. Let's write it as minus 11 halves. Now the last step, we're nearly in vertex form, but not quite, because we need this to be y equals something, not y over 2. So how do we make this be y? We need to multiply the left-hand side by 2. And if we're multiplying the left-hand side by 2, we need to multiply the right-hand side by 2. Now, a word of caution. It's easy enough to remember that you need to multiply this whole bit by 2 by just putting a 2 out the front. But you need to remember also to multiply this term by 2, and that will give you the minus 11 there at the end. Now we've got our vertex form, and we can read the vertex straight off. It will be x minus, we've taken off 3, and negative 11. This last one looks monic, but it's not, because the number out the front here is negative 1. So we can take care of that just like we took care of that 2. We can divide all 4 terms by negative 1, or multiply them by negative 1, same thing really. So we've got negative y is equal to x squared minus 8x plus 15. Now we can do our usual thing, leave a line and say we're looking for these 2 terms to come together with this arrangement. Because when we expand that back out, we'll get what we want with our x squareds and our x's. But whether we like it or not, when we square negative 4, we're going to get 16 along for the ride. So let's pretend that 16 was never there by adding it but then taking it away again. We've still got our 15. Now remember to compare your lines carefully. This line and this line need to be the same, with the only thing being different is being the plus and minus 16. We still have our negative y here. Now these 3 terms are taken care of here. So our leftovers, we have negative 16 plus 15, which is minus 1. But don't forget over here we've still got negative y. So our last step is to convert it so that it's y equals. Now what have we done to the left? We've multiplied by negative 1, or divide by negative 1, however you like to see it. So we need to do the same here, and we get negative x minus 4 squared. But don't forget to multiply this by negative 1 too, and we'll have plus 1. Now we can see the vertex is going to be 4, 1, and this is an upside down parabola.